Good morning, students. Now I am going to discuss the concepts of charged magnetic field or moving charge. So, first concept I am going to discuss here is force R or already derived force, right? Motion of charged particle in uniform magnetic field. So, how a charged particle will move in uniform magnetic field? So, first if you want to apply magnetic field on a charge, it should experience force, right? So, force on a charged particle in magnetic field is now only in the last class we discussed, right? Now, what is that? Force on a charged particle F is equals to QVB sin theta. F is equals to what ma? QVB sin theta. First case, if particle is moving along the direction of magnetic field, that is what? Theta is equals to 0 or 180. If you take that both cases, the result will be same. Means a charged particle is moving in a magnetic field parallel to magnetic field or anti-parallel to magnetic. For example, this is charge. It is moving with some velocity v here. Now we applied a magnetic field in this direction. Now, what is theta here? Angle between velocity and magnetic field. So, if theta is equals to 0, F is equals to QVB sin 0. So, what is the magnetic force on the charged particle? That is 0. The particle moves along straight line. So, when a charged particle moves parallel to the uniform magnetic field, the path of the charged particle is straight line. This is very important one mark question. That is, the path of charged particle when it is moving along the direction of magnetic field. When a particle is moving along the direction of magnetic field, its path is what? It can deviate? No, it moves along a straight line. Very important for one mark question. So, okay, now we learnt what is the path of the charged particle when it is moving along the direction of magnetic field or anti-parallel to the direction of magnetic field. If magnetic field is applied 180 degrees also, theta is 0. Now, there is the point that what happens when it moves perpendicular direction of magnetic field, right? Case 2. When charged particle is moving how? Perpendicular to magnetic field. When charged particle is moving perpendicular to magnetic field. So, let us see here. So, when a charged particle is moving perpendicular, for example, this is the charged particle. So, this is charged particle Q moving with velocity v in this direction. As we know that when a particle is moving in a circular path, it experiences the centripetal force. Here that centripetal force is what? Magnetic force, or centripetal force acting towards the center. And we applied the magnetic field. See, I am applying the magnetic field here uniformly on the surface. This is B. Means magnetic field is acting into the plane. So we can say that when a charged particle moves perpendicular to magnetic field, it moves in circular path due to magnetic force. So due to magnetic force, it moves in which path, ma? Circular path. So when it is moving in circular path, the centripetal force should be balanced by what? Magnetic force. So Fc should be balanced by Fm. What is Fc? mv square by r, centripetal force. What is the magnetic force acting on the charged particle? Q v b sin theta. Theta is how much? 90, because for this velocity the magnetic field is perpendicular. So this is velocity, this is magnetic field, so that both are perpendicular to each other. That implies v cancel from this. Sin 90 is 1, r is equals to mv by qb. So the question they can ask for, derive the expression for radius and angular frequency of circular motion of charge in uniform magnetic field. So the question, this they won't ask that this is the case. So I am writing here why I have left gift, because what is the question they are going to ask here? Derive an expression for radius and angular frequency of a moving charge or of circular motion of charge in uniform magnetic field. Okay, so this is the question they will ask. Derive an expression for radius and angular frequency of circular motion of charge in uniform magnetic field. So we come to know that when a charge is moving in perpendicular magnetic field, it moves in circular path. What the radius of circular path? We have concluded by using, so when a particle is moving in circular path, centripetal force should be balanced by magnetic force. Now we have to find what radius we already got. What about angular frequency? We know that there is a relation between velocity and angular velocity. What is that? V is equals to r omega. Substitute in 1. R is equals to m r omega by qb. R cancel. What is omega? What we want to find, that is omega. Angular frequency omega is equals to qb by m. Okay. From that we can find time period. Omega is equals to what? 2 pi f r 2 pi by t. If you substitute anything here, 2 pi f is equals to qb by m. That implies fb is equals to qb by 2 pi m. So here we have to note one important point, that the frequency of a particle moving in a circular path does not depend on speed as well as the radius of the circular path. So why? The magnetic force is always to the perpendicular direction of motion of the charged particle, hence the work done on the charged particle by the magnetic field is 0. So here we know relation between f and t. From this, t is equals to what? Sorry, reverse it, 2 pi m by qb. So what are things we observe here? F and t are, very important point this one, independent of speed and radius. F and T are independent of what? Speed and radius. If the speed increases, frequency does not changes, time period also does not change. So don't think and false assumption that if speed increases, frequency has been increased. No, here the frequency of charged particle moving in circular path does not depend on speed and radius. And one more point I am writing here only, that is here in this condition we can observe one important point. That what is the important point? The magnetic force is always perpendicular to the direction of the magnetic force is always perpendicular to direction of motion of charged particle. Hence, what is that? Work done. Work done is equals to 0. So these points we should remember after the results of this one. So this question will ask us, derive the expression for radius and angular frequency of circular motion of charged particle, which is important for 3 marks. Okay, students. So first point what we learned, when theta is equals to 0, the particle moves along straight line. When theta is equals to 90, the particle moves in a circular path. Now last one, motion of charged particle when it makes an angle theta with magnetic field. Motion of charged particle when it makes an angle theta with magnetic fields. For example, so this is a particle is moving with velocity v, and assume that the magnetic field is present along x axis. Okay. Now this is y and this is z. Now it is making how much angle? An angle theta with respect to magnetic field. You know, projectile, when a body is projected into space with respect to coordinate axis, the particle moves along x axis as well as y axis. Means this velocity component is divided into 2 components. One is along x axis as vx and another is along y axis as vy. Is it right? As we know, the horizontal component of velocity is what? V cos theta, and the vertical component of velocity is called what? V sin theta. So now this component velocity is divided into 2 components, so that as we already cleared that when theta is equals to 0, the magnetic force is 0, means it moves along straight line. So the V cos theta component, which is parallel to B, hasn't effect of magnetic field. So the magnetic field's force is 0, so it moves along which path? Straight line. Okay, it moves along straight line. This is which component? X component. Next one, what about this? This velocity is along y axis, which is perpendicular to magnetic field, right? So this particle moves in which path? Circular path. So Vx moves along straight line, Vy moves along circular path. Next, again the Vx component is parallel to magnetic field, so it moves along straight line. This moves along circular path. Same way it continues. So what happens finally? The particle moves which path ma? The combination of straight line and circular path, straight line and circular path, straight line and circular path. Finally what we get? That is called what? Helical path. Okay. So here the vertical component is undergoing force under magnetic force, so that we can say that here also Fc is equals to Fm, but here m v square by r is equals to what? QVB sin theta. So here we should write which component? We have to write v cos theta? No, because v cos theta is not undergoing any force, it is not moving circular path. So which component is moving? V sin theta. So we can write as m v square sin square theta by r is equals to QVB sin theta. So v sin theta get cancelled. From this, r is equals to mv sin theta by QB. Similarly, we can derive time period, right? Yes. So how can we derive time period? We can simply take the simple equation, t is equals to 2 pi r by v. What is r here? Substitute the value, 2 pi into mv sin theta by QB into velocity. Which velocity? Vertical component velocity v sin theta. Here v sin theta cancel. What do you get? T is equals to 2 pi m by QB. So if you reverse it, that you get frequency is equals to QB by 2 pi m. So frequency and time period hasn't changed in both cases. So T and F depends on B and specific charge, but independent of velocity. So finally we can prove that T and F depends on what factors ma? 2 pi is constant, Q by M is specific charge. So Q by M called as specific charge and velocity, and magnetic field independent of velocity. So here one more point we can get, that is called pitch. What is pitch here? This, the horizontal distance, the horizontal or linear distance moved by the charged particle along the direction of magnetic field in one rotation is called pitch of helix. So it is moving in which path? Helical path, and the shape is called what? Helix. Here what is pitch of helix? What is pitch of helix? The distance, the linear distance moved by the charged particle along the direction of magnetic field in one rotation. Definition is very important for 1 mark. The linear distance travelled by the charged particle along which direction? Along the direction of magnetic field in one rotation. In one rotation, how much distance has been travelled is called what? Pitch of helix. It is represented letter x. X is equals to what? Distance moved or velocity of the particle along the direction of magnetic field into time period. So velocity of particle along x axis into time period. What is the velocity of component along x axis ma? V cos theta into time period. What is the time period value? 2 pi m by QB. So this is called what? Pitch of helix. So from all these things what we learnt very important 3 points. First point is what? Theta is equals to 0 or 180. Yes. Path of charged particle is straight line. See, they will ask the question as, what is the path of the charged particle when a particle is moving along the direction of magnetic field? So what path it is moving? Straight line. For example, if The charged particle is moving perpendicular or tangent or normal, then the path of charged particle is circular. Next, last one, when theta is equals to theta means at an angle. Last case we discussed na, the path of charged particle is helical, that is called helix. Very important for 1 mark. Okay. Now we got a question that, sir, what is the direction of magnetic force experienced by the charged particle? Let us take that. So this is x axis and y as well as z. A particle is moving in a plane. This is charged particle moving in a plane with velocity v, making an angle theta with magnetic field. Here is magnetic field along y axis. Okay. And the charged particle is moving in xy plane, making an angle theta with magnetic field. You know, the magnetic force is along z axis. So this is the direction of magnetic force. How can we come to know that? So this is why should it has to be explained for long only z axis. So we have one rule. I am explaining the Fleming's left hand rule to direction of force on a positive charge particle. Fleming's left hand rule. So this rule is very simple, kana? You take your left hand, okay, and stretch like this. 3 should be mutually perpendicular to each other. So which 3 fingers? Forefinger, middle finger and thumb. These 3 are stretched mutually perpendicular to each other. So this represents the direction of magnetic field, and the central finger represents the direction of charged particle, that is velocity. This is magnetic field. Then the thumb points the direction of magnetic field. Direction of magnetic field. See here, for example, the particle is moving along which axis? X axis, and magnetic field is along y axis. Then my thumb is pointing towards along out of the plane, right? That is nothing but positive z axis. That is nothing but positive z axis. So this is the way to calculate the direction of force experienced by a charged particle by using Fleming's left hand rule. So what we done here? If the forefinger, middle finger and thumb are stretched perpendicular to each other. First we have to do that. We should stretch our 3 fingers perpendicular to each other. So then here, what forefinger represents? Forefinger represents what? What? Can you say that? What forefinger points that? Forefinger represents what? Direction of magnetic field. If we should consider the middle finger represent that velocity of charged particle, then thumb gives direction of magnetic force. So they will ask that state Fleming's left hand thumb rule. You have to explain. If the forefinger, middle finger and the thumb are stretched mutually perpendicular to each other, then the forefinger, if the forefinger represents magnetic field, middle finger represents velocity and the thumb points direction of magnetic force, then thumb points what? Direction of magnetic force. So, this is clearly about a motion of charged particle in presence of magnetic field. Thank you.